Just a few years ago, this environment consisted of PCs connected to a network, with servers providing file and print service. Remote access was awkward, and portability was achieved by use of laptop computers. Terminals attached to mainframes were prevalent at many companies as well, with even fewer remote access and portability options. Web technologies are stretching the boundaries of traditional computing. Handheld PDAs can connect to wireless networks to use myriad web resources. In the latter half of previous centuries, systems were either batch or interactive. Batch systems processed jobs in bulk. Interactive systems waited for input from users. Multiple users shared time on these systems. The time-sharing system used a timer and sharing algorithms to rapidly cycle processes through CPU. And the distributed system. A distributed system is a collection of physically separate, possibly heterogeneous computer systems that are networked to provide users with access to the various resources that the system maintains. Access to a shared resource increases computation speed, functionality, data availability, and reliability. Some operating systems generalize network access as a form of file access, with the details of networking contained in the network interface's device driver. Others make users specifically invoke network functions. Generally, systems contains a mix of the two modes. The protocols that create a distributed system can greatly affect the system utility and popularity. Advantages of distributed systems is resources sharing, computation speed-up, load sharing, reliability, and communications among the computers in the distributed systems. TCP/IP is the most common network protocol, and it provides the fundamental architecture of the Internet. Most operating systems support TCP/IP, including all general-purpose ones. Some systems support proprietary protocols to suit their needs. To an operating system, a network protocol simply needs an interface device, a network adapter, for example, with a device driver to manage it, as well as software to handle data. A network operating system is an operating system that provides features such as file sharing across the network, along with a communication scheme that allows different processes on different computers to exchange messages. A computer running a network operating system acts automatically from all other computers on the network, although it is aware of the network and is able to communicate with other networked computers. A distributed operating system provides a less autonomous environment. The different computers communicate closely enough to provide the illusion that only a single operating system controls the network. Mobile computing. Mobile computing refers to computing on handheld smartphones and tablet computers. These devices share the distinguishing physical features of being portable and lightweight. Combined with desktop and laptop computers, mobile systems give up screen size, memory capacity, and overall functionality in return for handheld mobile access to services such as email and web browsing. Because power consumption is such a concern, mobile devices often use processors that are smaller, are slower, and offer fewer processing costs than processors found on desktop. Two operating systems currently dominate mobile computing: Apple iOS and Google Android. iOS was designed to run on Apple iPhone and iPad mobile devices, while Android powers smartphones and tablet computers available from many manufacturers. Client-server computing. As PCs has become faster, more powerful, and cheaper, designers have shifted away from centralized system architecture. Terminals connected to centralized systems are now being supplanted by PCs and mobile devices. Correspondingly, user interface functionality, once handled directly by centralized systems, is increasingly being handled by PCs. As a result, many of today's systems, such as server systems, to satisfy requests generated by client systems. This form of specialized distributed system, called a client-server system, has the general structure depicted in the following picture. This one. Okay. Server system can be broadly characterized as compute servers and file servers. Compute server system provides an interface to which a client can send a request to perform an action. In response, the server executes the action and sends the result to the client. A server running a database that responds to client requests for data is an example of such a system. The file server systems provides a file system interface where clients can create, update, read, and delete files. An example of such a system is a web server that delivers files to clients running web browsers. Peer-to-peer computing. Another structure for a distributed system is the peer-to-peer system model. In this model, clients and servers are not distinguished from one another. Instead, all nodes within the system are considered peers, and each may act as either a client or a server. depending on whether it is requesting or providing a service. Peer-to-peer systems offer an advantage over traditional client-server systems. In a client-server system, the server is bottleneck, but in a peer-to-peer system, services can be provided by several nodes distributed throughout the network. Determining what services are available is accomplished in one of two general ways. The first, when a node joins a network, it registers its service with a centralized lookup service on the network. Any node desiring a specific service first contacts this centralized lookup service to determine which node provides the service. The remainder of the communication takes place between the client and the service provider. An alternative scheme uses no centralized lookup service. Instead, a peer acting as a client must discover what node provides a desired service by broadcasting a request for the service to all other nodes in the network. The node providing that service responds to the peer making the request. To support this approach, a discovery protocol must be provided that allows peers to discover service provided by other peers in the network. Weixin is an example of peer-to-peer computing. It allows clients to make voice call and video call and to send text messages over the internet. Weixin uses a hybrid P2P peer-to-peer approach. It includes a centralized login server. It also incorporates decentralized peers and allows two peers to communicate. Virtual machines. Virtualization is a technology that allows operating system to run as applications within other operating systems. At first blush, there seems to be little reason for such functionality, but the virtualization industry is vast and growing, which is a testament to its utility and importance. Virtualization is one member of a class of software that also includes emulation. By virtualization, in contrast, an operating system that is natively compiled for a particular CPU architecture runs within another operating system also native to that CPU. Virtualization first came about on IBM mainframes as a method for multiple users to run tasks concurrently. Running multiple virtual machines allowed many users to run tasks on a system designed for a single user. Later, in response to problems with running multiple Microsoft Windows XP applications on the Intel Xpadio CPU, VMware created a new virtualization technology in the form of an application that can run an XP. A virtual machine provides an interface identical to the underlying hardware. Each process is provided with a virtual copy of the underlying machine. By virtual machine, we can run several different operating systems on the same hardware. On laptops and desktops, a virtual machine manager allows the user to install multiple operating systems for exploration or to run applications written for operating systems other than the native host. For example, an Apple laptop running Mac OS X can run a Windows guest to allow execution of Windows applications. Advantage of virtual machines. The virtual machine concept provides complete protection of system resources since each virtual machine is isolated from all other virtual machines. This isolation, however, permits no direct sharing of resources. A virtual machine system is the perfect vehicle for operating system research and development. System development is done on the virtual machine instead of on a physical machine and so does not disrupt normal system operation. Disadvantages of virtual machine. The virtual machine concept is difficult to implement due to the effort required to provide an exact duplicate to the underlying machine. The underlying machine has two modes, user mode and kernel mode. The virtual machine itself can execute in only user mode. The virtual machine must simulate a virtual user mode and a virtual kernel mode, both run in a physical user mode. Clouding computing. Clouding computing. Cloud computing is a type of computing that delivers computing, storage, and even applications as a service across a network. In some ways, it's a logical extension of virtualization because it uses virtualization as a base for its functionality. For example, the Amazon Elastic Compute Cloud facility has thousands of servers, millions of virtual machines, and petabytes of storage available for use by anyone on the internet. Users pay per month based on how much of these resources they use. There are actually many types of cloud computing, include the following. Public cloud, a cloud available via the internet. A cloud available via the internet to anyone willing to pay for the service. Private cloud, a cloud run by a company for that company's own use. Hybrid cloud, a cloud that includes both public and private cloud components. Software as a service, one or more applications available via the internet. Platform as a service, a software stack ready for application use via the internet. Infrastructure as a service, servers or storage available over the internet. These cloud computing types are not discrete, as a cloud computing environment may provide a combination of several types. For example, an organization may provide both SAS and IaaS as a publicity of available services. There are traditional operating systems within many of the types of cloud infrastructure. Beyond those are the VMS that manage the virtual machine in which the user processes run. At a higher level, the VMMs themselves are managed by cloud management tools such as vWire vCloud Director and the open source Uclipse toolset. These tools manage the resources within a given cloud and provide interfaces to the cloud components, making a good argument for considering them a new type of operating systems. So here you can see they are servers and storage and cloud management services. This is cloud customer interface, and this is firewall. So through the internet, the customer asks a request and then use the cloud resources. Real-time embedded system. Embedded computers are the most prevalent form of computers in existence. These devices are found everywhere, from car engines and manufacturing robots to DVDs and microwave ovens. They tend to have very specific tasks. The systems they run on are usually primitive, and so the operating systems provide limited features. Usually, they have little or no user interface, preferring to spend their time monitoring and managing hardware devices, such as automobile engines and robotic arms. These embedded systems vary considerably. Some are general-purpose computers running standard operating systems such as Linux, with special-purpose applications to implement the functionality. Others are hardware devices with a special-purpose embedded operating system, providing just the functionality desired. Yet others are hardware devices with application-specific integrated circuits that perform their tasks without an operating system. Embedded system almost always run real-time operating system. A real-time system is used when rigid time requirements have been placed on the operation of a processor or the flow of data. Thus, it is often used as a control device in a dedicated application. Sensors bring data to the computer. The computer must analyze the data and possibly adjust control to modify the sensor inputs. Systems and control, scientific experiments, medical imaging system, industrial control system, and certain display systems are real-time systems.